Alrighty. The other video I wanted to do today is going to be on Lagrange multipliers. So again, remember that this is finding the critical points of a multivariable function, but given some constraint on the variables, right? So it's pretty easy to find the critical points, but now we have to account for some constraint, some restriction on what our variables can do. Cool. Recall that if I have a constraint like this, I want to create g of x such that it's this set equal to 0. So 2x plus y minus 10, which would equal 0. Cool. That gives us our capital F of x, y, and lambda, which is f of xy minus lambda g of xy. So this is actually g of xy, not just g of x. Y. Cool. That's going to be 25 minus x squared minus y squared minus lambda times 2x plus y minus 10. And we're going to find the first partials with respect to f of x, or with respect to x, y, and lambda. Right. Cool. So the partial with respect to x is going to be minus 2x from this, and then minus 2 lambda. If I multiply this lambda and this 2x, I get minus lambda times 2x, so minus 2 lambda x. And I partial that, so I get minus 2 lambda. I'll set that equal to 0 and do the same for y and lambda. Y gives me minus 2y minus lambda equals 0. And lambda gives me the negative of what's in these parentheses. So minus 2x minus y plus 10, and that's equal to 0. Cool. Now to solve a system like this, the trick is to usually solve the first two, solve fx and fy, such that we eliminate lambda. So I can multiply this bottom by 2. That gives me minus 2x minus 2 lambda equals 0. Multiplied by 2, I get minus 2y, or I should say multiply by negative 2, so that when I add them together, they cancel. So this is 4y plus 2 lambda equals 0. The lambdas cancel, and I get minus 2x plus 4y equals 0. So all I've done is I've solved this system such that I cancel out lambda. And now I'm going to combine this result with my f sub lambda so that I can solve for x and y. So I have minus 2x minus y. I'm going to move that 10 over, so that equals minus 10. I'm going to make the bottom negative, so I'll just put a plus sign on everything. But I multiplied it by negative 1, such that when I add these together, I get just 5y equals 10, which means y equals 2. Cool. Now that I have y equals 2, let me utilize this space. I can plug that into my constraint and solve directly for x. So I know that 2x plus y equals 10. That means 2x plus y is 2. 2 equals 10, or x equals 4, right? 10 minus 2 is 8. Divide by 2, we get 4. So our critical point is at x is 4, y is 2. And that would be how you go through and do the method of Lagrange multipliers. Note that it really wasn't that difficult. The only thing we had to do is we had to solve two systems. We solved this system, so the system of fx and fy, which gave us a value, and then solved that system with f lambda to get y, canceling out the x's, and then plug that value of y into our constraint to solve for our other variable. Cool. So not bad, just remembering our things. We have to set the constraint equal to 0, plug that in, multiplied by lambda to our function, take the partials, set equal to 0, and solve that system of equations. That's all I have for this video. If you have any questions, feel free to email me or leave it in the comments, and thanks for watching.